Hi, everyone. Good morning, good afternoon, good evening. Where is everyone tuning in from? I see that people are joining. I'm Kirby Koo. I'm on the marketing team here at Chainguard, and today we're going to be going over FIPS images with Adrian. I always like to start out by asking where everyone's tuning in from, so just comment in the chat. Bend, Oregon. Okay. Atlanta, Georgia. South Carolina. Redstone Arsenal. Wow, okay. Mostly in North America so far. Oh, Warsaw, Poland. Asheville, North Carolina. Woohoo! Okay. Well, I know you're all here to learn more about FIPS images with Adrian, so I just wanted to go over a couple of housekeeping items. You'll see that you can ask a question under the Q&A tab here in the chat, or you could ask it in the chat, and we'll be sure to get that addressed for you if we know the answer. If not, we'll definitely get back to you. And then if Adrian suddenly starts talking to himself, it's because I'm in his ear backstage and he can hear me, but you guys can't. So he's not possessed or anything. He's just listening to the producer, or that would be me backstage. So, all right. Well, without further ado, Adrian, the stage is yours.
Okay, thank you, Kirby. I feel like I should say I'm in Edinburgh now, given everybody else is. But I'm in Edinburgh, Scotland, given everybody else has mentioned where they're from. So let me bring the slides up. I think it's that one. So hopefully you can see my slides now, and I'll get my notes. That looks good. Yeah, so this lab is on FIPS container images. Yeah, so I'm Adrian Mote, a technical community advocate at Chainguard, or DevRel, if that's easier. I did a long time ago write a book called Using Docker for O'Reilly. If you want to find me on social, it's usually fairly easy because my surname is relatively unusual, given it's spelled M-O-U-A-T. But yeah, you can find me on X and LinkedIn and Blue Sky now as well. And you can also send an old-fashioned email to adrian@chainguard.dev. So in this lab, we're going to start off by talking a little bit about Chainguard, and then we'll go straight into the FIPS material. So I'll give an intro to what FIPS is before going through FIPS compliant container images. There is a demo. I will warn you now, the demo, normally do a demo that everybody can follow along. And you can to some extent in this demo, but unfortunately for part of the demo, you'll need a FIPS image, and the FIPS images aren't freely available. And then we'll end up by talking about what a kernel-independent FIPS image is. Okay. So for the demo, all you're going to need is a Docker engine. So you can do a Docker pull and Docker run. You'll be able to follow along with the public part of it. Oh, so a few words about Chainguard first. Chainguard's mission is to be the safe source for open source. So we want you to be able to come to Chainguard whenever you need to use open source software and want to do it in a secure and verifiable manner. So definitely thinking about supply chain security. We have over 100 customers across various industries, and that does include regulated industries such as defense and healthcare, which is partially where all the FIPS comes in. So our main product at the minute is Chainguard images. So these are minimal security hardened container images with 0 CVEs. And we've created over 1,200 images so far, and they've all been in response to customer demand. So generally we produce an image because people are asking for it. That includes both FIPS and non-FIPS images. So I think there may be around 400 FIPS images. So just to be a bit clear about the value prop, here's the result of scanning the Chainguard Python image compared to the Docker official Python image. And this scan is done with Gripe, and it shows it over the last 30 days. So on the left, we have the Chainguard image, and you can see down the bottom, there is one day, I think it's the 5th of December or so, where there was a single medium vulnerability in the Chainguard image. The gray bars are days that we have data missing for some reason. I'm not quite sure. I'll talk to the team about that one, but that's missing data, so we can't say anything about those days. And on the right is the Docker official image. So this is a Debian-based latest image, and you can see it's hovering around 200 vulnerabilities, including critical and high ones. So that's a difference between the images, roughly. And that opens us to the question, why does the Chainguard image have so many less CVEs? And there are a few things, really. So the first one is our images are minimal. So we only include the packages and dependencies required to run the application. So for our production images, that typically includes moving even the shell and package manager. And by having smaller images with less software in them, there's simply less things to have as a CVE, if you like. The second thing, and probably the biggest thing, to be honest, is we're constantly rebuilding from source. So if an upstream project releases an update or a fix, we'll typically get that fix on the same day and have an updated image in a few hours. And if you compare that to, say, a Debian or Alpine-based image, you're going to need to wait for that project to update the repository with a new version of the package for that. And then you're also going to need to wait for Docker or whoever builds the image to produce a new image based on that new package. So you're talking like a lead time of weeks as compared to hours for Chainguard. And the third thing is we also investigate any CVEs that are found in our images and reported by tools like Gripe or Sneak. And if we find, and so sometimes we'll find like a CVE is a false positive. For example, maybe flagging a CVE on a Linux package, but the CVE only exists in the Windows package. In that case, we can issue a security advisory and mark it as a false positive. The scanners will pick that up and remove it from the list. Okay, so that's enough about Chainguard right now. I want to move on to talking about FIPS. So I'm guessing that most people here probably already know something about FIPS before you joined this webinar, or want to at least. But let's start at the beginning so that everyone's on the same page. So FIPS stands for Federal Information Processing Standards. It's a set of computer security standards that you're going to need to meet if you want to work with the US or Canadian federal government. They're developed by NIST, which is the National Institute of Standards and Technology. There is a lot of acronyms involved with FIPS, I'm afraid. And NIST is a US government agency. You might also come across FIPS in some other contexts in other countries, as sometimes organizations and countries will reuse the work by NIST rather than do it all by scratch themselves. But FIPS becomes super important if you want accreditation with a compliance program, especially FedRAMP. Now, if that's not the case, say you're not working with government and you're just interested in FIPS as you want to know about security standards and so on, I would recommend that you look at other options first. So FIPS tends to be very expensive. And in most cases, the easiest way to improve your security will be to spend that money elsewhere, such as on security audit or infrastructure, or security audit of infrastructure and code, for example. But it does tend to be very self-selecting. So if you need FIPS, you know what it is. And if you don't know what it is, you probably don't need it. And actually, on that point, can we do a quick poll in the chat? Can you mention why you're interested in FIPS? So is it for FedRAMP, or is it for compliance or regulation framework, or a different framework, or is it just something else? Yeah, FedRAMP. Yeah. I think that's going to be the main one. Yeah. Thanks, Kirby. DISA. I'm not even sure what that one is, I have to say. Future-proofing? Okay. DoD, yeah. So FIPS is a set of standards. For the purposes of this talk, we're really only interested in two, which is FIPS 140-2 and FIPS 140-3. Now, FIPS 140-3 is actually a replacement for FIPS 140-2, but there is a transition period until September 2026, and until then, validation certificates under either standard are valid. Now, the standard covers what NIST calls cryptographic modules, and that does cover quite a lot of ground, but you're primarily thinking about digital signatures, secure hashing, things like SHA-512, but also symmetric and asymmetric encryption, so AES, DES, ECDSA, and various more acronyms. As you're probably aware, usage of these functions is very common and widespread. All, especially so in networking, so all HTTPS communication uses TLS in some form of encryption. Click the wrong thing. There we go. There is multiple levels in FIPS. Level 1, so if you go and look at a certificate or so, and you'll see that there's different levels and they all build on each other. So level 2 is level 1 plus some things in level 2. But level 1 is a bit that talks about algorithms and security functions in terms of software. Higher levels also bring in physical security, so things like tamper-evident seals on hardware and things like that. Because we're just going to be talking about containers and functions in this lab, we're generally talking about level 1. And Chainguard certificates are level 1. You will hear the words validated and compliant a lot when talking about FIPS. And it does pay to be a little bit careful here. In general, people will talk about achieving FIPS compliance by using FIPS validated cryptography. And validated is sort of the key word you need to look out for. It means that a product, or more accurately, a cryptographic module, has been tested in a lab and shown to meet FIPS standards. And FedRAMP requires that all cryptography used within the system has to be FIPS validated and certificates to be available. Now, to achieve FIPS validation for a product, you go through another acronym, which is CMVP, or the Cryptographic Module Validation Program. That's bureaucratic and expensive. You can search online for certified products and products currently in certification, and you'll get an idea of what's involved and why it takes months and quite often years to get through the process. So rather than apply for validation, it's much better to license or reuse existing validated modules wherever possible. Somebody's asking about FIPS certified. I should probably get someone that's more certain of exactly all the terms to reply, and I guess we will get that. But FIPS validated is the key term. You go and look online. I think when people talk about FIPS certified, that's probably people talking in a looser fashion. It does get confusing. Definitely you want to look for FIPS validated though, and the actual certificates. NIST does not carry out the testing themselves. Instead, they work with cryptographic and security testing labs, which have been accredited by NIST. There isn't that many of these labs, and you will be unsurprised to learn that they are mainly in the USA. And that brings us on to what certificates do we use in Chainguard. So you can get the full information on edu.chainguard.dev, but basically the main one we use is CVMP 4856, which is a Chainguard OpenSSL FIPS 3 provider module. We also have a certificate for an entropy source, and we'll get into that more later when we talk about the kernel independent FIPS images. But basically, when you're using FIPS, you also need to make sure you get your source of randomness is certified. Now, there are also Java FIPS images, and we have Java FIPS images, and those use certificates from the Legion of the Bouncy Castle. So our Java images are configured to use the crypto module from Legion of the Bouncy Castle. And they have two certificates here. One is the older 142, and one's the new one. I think that's the new one first, the newer 143 one. I think the 142 one is marked as historical, but I expect it's still valid for the minute in certain contexts. So there are currently around 400 FIPS images, both applications, so things like Postgres and Nginx, and languages, base images like JDK and Go. These are not on the free tier of Chainguard images. So the majority of our Chainguard images are OpenSSL based. So they're using that OpenSSL certificate that I mentioned later in our Chainguard OpenSSL FIPS module. Yeah, and in Java ones, you also find the Bouncy Castle Java libraries. Okay, I'm going to do a bit of a demo if I can figure out how to share my terminal. There we go. Windows, what I want, isn't it? That looks hopeful. Okay, so hopefully you can see my terminal, and that looks fairly big. Cool. Right. So, well, actually, I'm going to copy and paste this because it's quite a long command, and I will get it wrong. So I'm going to start by running a regular Nginx image. So you can follow along and run this yourself. It's the cgr.dev/chainguard/Nginx latest dev image. So this is freely available, and you can try it yourself. So here we have, I'm changing the entry point to bin sh because I want to get to get a shell inside it, which is also why I have -it. And we're also setting the user to root so that I can install things with APK. Okay, so if I do APK update, it should work. And I can do APK add OpenSSL-FIPS-test. So Chainguard have created a simple program to test for FIPS compliance. And if you go onto the Chainguard, this is available, this is open source and available on GitHub, so you can go and check it out if you like. It's not anything complicated. All it does is test whether or not the OpenSSL module is configured to use FIPS. You can't assume that even if it gives you a passing mark that your image is FIPS compliant. So if we run that, yeah. So this is not the FIPS image, so we get a fail. Another thing we can have a look at, APK add OpenSSL. So by default, although OpenSSL is installed, OpenSSL CLI isn't. So I've installed OpenSSL CLI, and now I can do OpenSSL and you can see the only provider here is the OpenSSL default provider. So this gives us the default set of crypto algorithms that you get with OpenSSL, if you like. I think we can even list them if I can remember and you'll get a very long page of algorithms. How did I spell algorithms wrong? There we go. Yeah, so you get a very long list of algorithms there. Okay, so that's what the default Nginx image looks like. Let's take a look at the FIPS image. So doing exactly the same thing, but this time I've used Nginx FIPS image. So you won't be able to do this unless your organization has subscribed to the Nginx FIPS image. But I just want to show you what it looks like and how it's different from the other image. So this comes with OpenSSL FIPS test installed. And this time, I'm hoping we get a pass. And we also get a lot more data on a few test stats run. So it's checked, a few algorithms are available. And it's also run a check to make sure certain things are not available, which I guess is really the point of FIPS, that you can't be using insecure crypto. So for example, MD5 is not available. And if I do APK update again. I do APK add open SSL again. And now I can do open SSL list providers, and we get a different answer. Now, interestingly, there's two things here. Before, it said OpenSSL default provider. So OpenSSL base provider is not the same as default provider. OpenSSL base provider, it turns out, does not give you any crypto functions. It has a few sort of helper functions for things like serializing and deserializing keys. There's no crypto that happens in the base provider. All the crypto algorithms are in this FIPS provider. And so this is the same one that we have the certificate for. And you can see it's pinned to this version 309. Probably the nicest way to see the actual algorithms is to run Nginx and play with Nmap. So I have a Docker file here. Hopefully it's correct. So basically we're using, this is again using the free version. So we're first going to test the free tier version of Nginx, and you can follow along if you like. So all I've done is use that image, set it to Nginx, and then I'm copying a config file. And I'm also copying in certificate and private key. These are just, I just created this with CF SSL. So it's very simple to create. Okay, so if I do build. So yeah, let's build that image and hopefully it'll build. I have edited it, so it may have gone horribly wrong. Now that's built. And if you run this, we will give it port, I hope this port is free. So I'm going to do port 8443 in the host, put that to port 443 in the container, and it's non-FIPS image we just built. So that looks right. Now, to curl this, we do need to tell it about the certificate, because this is a self-signed certificate. It doesn't have it in the chain. But if I pass the cert on the command line, curl can talk to localhost, and you get that back. Just to, if I don't give it a certificate, you get an error about it. And as you probably know, you can pass -K for insecure, and that will also work. So that's curl working with our Nginx and a self-signed certificate. Now, remember, this is the regular version, not the FIPS version. If I hit it with Nmap, what have I done? Oh, localhost. If I hit it with Nmap, that should tell us a little bit about which ciphers it thinks are available. It'll just take a moment to run, unfortunately. Right, and so it's got a whole bunch of things. So there's TLS 1.2 and TLS 1.3. Note there's things like Camellia and Cha-Cha here, and also AES 128. So if we change this Docker file, and this time we're going to use the private Nginx FIPS image, but leave everything else the same. And Docker build that. And this time I'm building the FIPS version. That looks good. We'll run that. We still have the old one running, so I'm going to use a different port. And this is FIPS. Okay, and then we can curl it again. Let's use the cert. Okay, so that's working. And the interesting one is the Nmap. So again, change to port 442. And this time we should see something slightly different. Really, the only difference is that FIPS does not have, the FIPS module does not have various unapproved ciphers. So in this case, you'll see there's none of the Cha-Cha ciphers and there's none of the Camellia ciphers. And that's really what it means to be using FIPS approved cryptography. All these ciphers have been approved by the FIPS standard. And really, that's all I have for the demo. I guess I should take questions on this part before I move back to the slides. Oh, well, there's some questions here. Yeah, that's a good question about historical. I think there is some wording on the page that Lisa shared in her docs about how that certificate can be used. So remember, there's two Bouncy Castle certificates, a new one for 140-3 and the old one for Bouncy Castle 1.x, which is 140-2 certificate. My understanding is that if you have an existing installation and are using the 140-2 certificate, you are okay until September 2026. Do not take my word for that. Please double check and ask your auditor, quite frankly. That's the big thing with FIPS is, yeah, double check everything. Don't trust anybody and work with an auditor. Are these tests the same provided as part of the CMVP? No, this we are not doing to be honest, I don't know what tests the CMVP go through. This is it's not checking for a local manifest. It is a little bit more complicated than that. I do have well, I can find if you give me one moment, I'll find the GitHub repo and you can see exactly what it does. Or if somebody else wants to find that for me, I won't complain. Chainguard shell FIPS test. No, I can't. There we go. Chainguard dev OpenSSL FIPS test is what I want. Oh, thank you, Lisa. Yeah. So in the comments, you now see Chainguard dev OpenSSL FIPS test. If you follow that, you'll see exactly what that test does, and it's not going to be anywhere near as comprehensive as a CMVP test. It's literally just checking the OpenSSL provider is configured correctly, and there's a bunch of caveats on that page about exactly what it does. FedRAMP marketplace certification. My understanding is that regarding FedRAMP, that's more on the customer side. So, for example, if you were using our FIPS images, you would pull those into your registry, and that registry would be in your FedRAMP boundary. And the Chainguard itself would be outside. I don't know anything more about that, or if we're seeking certification, I'm afraid. Oh, there are some more questions over here. Yeah, that sounds good. Okay, I think we're good. I'm going to go back to the slides now. I think Chainguard is like an external service. Again, I'm a little bit hesitant to give definitive answers, but that's my understanding, yes. So you would, if you buy Chainguard images, what most of our customers do is they have their own registry and they either mirror or pull the images into their registry. And that registry would then be in your FedRAMP boundary. That's my understanding. Yeah, thank you, Mike. Okay, I'm going to go back to the slides. No, I need my other window. There we go. Okay, there are some major caveats with everything in FIPS, especially if you, well, particularly if you modify the images. So if you add anything to a FIPS image, you're going to be responsible for making sure it's not breaking like FIPS compliance. Now, you probably won't implement crypto yourself, but what you may accidentally do is use something that pulls in a dependency that unknowingly pulls in a non-FIPS validated crypto library. And if you do that, you've got a very big problem. So be very, very careful with any changes you make to FIPS images. Our OpenSSL FIPS test, yeah, this may be useful, but it's not going to prevent you from making those kinds of mistakes. Yeah, so do not trust, feel free to use it, just don't trust it blindly and double verify anything you change. And that brings us to of the really interesting things that we've worked on recently, which is to do with FIPS kernel-independent images. So traditionally, FIPS workloads have required a FIPS-validated kernel. So you would require both FIPS images and the FIPS kernel to run a FIPS workload. But quite often, the FIPS kernel is only required for a source of entropy. Entropy being like how the crypto algorithms get their randomness. And FIPS requires a certified entropy source. Now, Chainguard have created kernel-independent FIPS images, and these images have their own source of entropy within the image, within user space. And that means, in some cases, you can be FIPS compliant regardless of which kernel you are using. Now, that's quite a big deal in some cases, because most FIPS kernels tie you to old versions of the kernel, because that was what was validated. FIPS is for a particular binary, so you can't just update the binary. If you update the binary or the kernel in this instance, you have to get re-FIPS. You have to rerun the certification process and be validated again. And that means you quite often, if you have a FIPS kernel, you get tied to old versions of software, which isn't great. And at Chainguard, our images can help you break this dependency and run on up-to-date, secure versions of foundational source. I see, is this entropy source patented? I don't believe so. There's a certificate for it. I can go back to the slide with certificate number if you like, and you can look it up. I don't think it's anything particularly novel. It's a CPU jitter. It's just that it's not in the kernel. That's the only big difference. I'm pretty sure it'll be all open source as well, to be honest. Okay. Now, again, a big caveat. You'll be responsible for making sure that anything you use does not use the kernel for anything crypto related, including entropy. And there are some major things that you can't do then. So you can't use Java, so our Java images are not kernel independent. You can't use full disk encryption, that requires kernel support. You can't use kernel VPN modules, and you can't use various Kubernetes CNI stuff, also requires the kernel to be FIPS validated. So Ronald, regarding your question, my understanding is, well, FIPS requires you to have all crypto uses a validated module. So as long as that happens, you're okay, and it doesn't matter about the kernel. So if no crypto is happening in the kernel, it doesn't matter which kernel you run on. I hope that helps. If you do have more questions, please send them to us, and I will get one of our engineers who worked on this to answer, or someone with more knowledge, at least on exact legalities around FIPS. I am always a little bit scared to answer some of these questions. The last thing I wanted to mention was STIGs. So this comes up quite a lot in FedRAMP and regulated environments. Basically, a STIG, or Secure Technical Implementation Guide, is an implementation guide for how to make sure a software package, in our case, an image, is properly hardened against attacks. So all Chainguard FIPS images come with STIGs that can be automatically validated with SCAP tooling. And the long and short of it is that should save you a lot of time when doing FedRAMP or similar compliance. And again, there's a big EDU page on that. I can actually copy that. So I have the link here. Yeah, and Lisa, thank you for the link about kernel independent FIPS images. Yeah, FIPS and STIGs, yes. Yeah, they don't make it easy for me. Okay. That's pretty much all I wanted to talk about. If there's anything you should take away from this talk, it's that FIPS is complicated. touches a lot of places. It's expensive. It's bureaucratic. Some people do underestimate this and try to go the DIY route. I mean, sometimes you have to. And what we would say, or our CTO at least would say, is he would tap the sign on his wall, which reads, "We do these things not because they are easy, but because we thought they were going to be easy." And in the case of FIPS, I can very much assure you that it's not going to be easy, and it's definitely not going to be fun. I had a hard enough time writing these slides. Okay, so yeah, that's all I have. Oops, there we go. Yeah, I'll try and take any further questions. Do customers have responsibilities to ensure they are using Chainguard images per the applicable security policy contained in the FIPS validation? My guess is yes. Yeah, I'm sure, like, in various images, you can turn encryption off and so on. That's probably wouldn't be a good thing. Usually hosted FIPS enables an entire process requires FIPS. Yeah, FIPS requires you pulling an image. Yeah, I can't speak to that, I'm afraid. I think that's a valid concern. Yeah. Yeah, and Ronald, to be fair, I did mention that in the caveat slide. Is there... How did the kernel in place? Just binding the unfully functional FIPS compliant Linux distro. It's not necessarily the containerization. It's containerization. Sorry, Antifa Chad asked how do the remind me not to read the names. Asked how do the kernel independent images work? Are they just bundling their own fully functional FIPS compliant Linux distro within the image and then nesting the containerization? No, they are just normal container images. So you will be responsible for how the images run. And it's just that everything within all the crypto happening in that image or in that container is handled within the image itself. I think we've answered Ronald's question. Is there anything else I haven't mentioned? Okay, I think I've answered everything, hopefully. It must be a large percentage of breakaway. Yeah, exactly. It's not going to be, not everybody will be able to use kernel independent FIPS images, but hopefully some workloads can. And old kernels are a serious problem. Yes, it's a little bit unfortunate that, using a security standard forces you to use old versions of software, which I'm sure wasn't the intention. Yeah. Is there any more questions? Okay. Thank you very much, Mike. Yeah, thank you, Ronald. Okay. I think that's us. Thank you very much. Kirby, do you have last words?
No, I think that was great. Thank you so much for the chat. Again, I put my email there, kirby@chainguard.dev, if you have any questions we didn't address, and we'll try to get that to the experts at Chainguard. And I guess we'll see you next month for the upcoming Learning Lab on Go Static.
Well, am I back for that? I think I am. Okay. I'll see you all then.
Again. Yep. See ya. Bye.
Okay. Bye, everybody.